So in this question, we got to show that if we have an even potential, one that looks like this, for example, where we have some arbitrary potential, non-zero potential up here, and this potential down here is equal to 0. This is, of course, being the x-axis. That if we have an even potential that looks like this square well, which is going to be coming up later in quantum mechanics. So we need to show that if we have that kind of potential, then this version of the time-independent wave function is actually a solution to the Schrodinger equation as well. So we'll begin by, of course, writing out the time-independent Schrodinger equation. So the whole goal is to show if that is also a solution, assuming that this is true. We'll go ahead and put that minus sign into the wave function. Right? And we're also assuming this is true here, so we'll go ahead and put that minus sign into this potential here. Right, so I guess we'll work from the left over to the right then. So looking at this term here, if you take a single derivative of this, and assuming that that single derivative is positive, then taking this second derivative of it is also going to be positive. But if this is actually negative, then taking a single derivative of this will actually make this negative. But if you take another derivative of it again, then that'll get another negative sign, and then this will end up being positive. So no matter if this is even or odd, this whole term is going to be the same. So we went ahead and showed that this is unchanging, whether or not this ends up being positive or negative in respect to x or dx here, right? And so the next portion is showing that this is unchanging, and of course, luckily, we have this assumption that we have up here, so we can just go ahead and change this term to this term here thanks to this relationship. So let me go ahead and erase it, right? And then this energy out front is just a constant, right? So this whole thing looks like the normal time-independent Schrodinger equation, right? So this shows that this is actually a solution because everything out front here looks the same as their original time-independent Schrodinger equation, thus showing that this is actually a solution.